In the previous lessons, we learned about sets and the different operations that can be performed on them. Now, we'll move to the next important topic, relations. Relations help us understand how elements of one set are connected to elements of another. Before studying functions, it's essential to understand relations because every function is actually a special type of relation. So, let's build this concept step by step. Imagine a classroom where every student is connected to their roll number or every country is connected to its capital city. These are examples of relationships between two collections of objects. In mathematics, such relationships are called relations. To understand relations, we first need to learn about ordered pairs. An ordered pair is written in the form AB, where the first element belongs to one set and the second element belongs to another. The word ordered is important because the position of the elements matters. For example, the ordered pair 2, 3 is different from 3, 2. Even though both contain the same numbers, changing the order changes their meaning. Now, suppose we have two sets, A equals 1, 2, and B equals AP. What are all the possible ordered pairs we can form? We pair every element of A with every element of B. This gives us 1A, 1B, 2A, and 2B. The collection of all these possible ordered pairs is called the Cartesian product of A and B, written as A times B. A simple way to remember this is that the Cartesian product contains every possible combination of elements from the two sets. If one set contains two elements and the other contains three, then the Cartesian product will contain 2 times 3 or 6 ordered pairs. In general, if set A has m elements and set B has n elements, then the Cartesian product A times B contains m times n ordered pairs. Now let's understand what a relation is. A relation is simply any subset of the Cartesian product. This means we do not have to select every ordered pair. We only choose the pairs that satisfy a particular condition. For example, let A equals 1, 2, 3 and B equals 2, 4, 6. Suppose we want to connect each number in A with its double in B. The required ordered pairs are 1, 2, 2, 4, and 3, 6. These selected pairs form a relation from A to B. Notice that although the Cartesian product contains many possible pairs, the relation contains only those pairs that satisfy the given rule. Every relation has three important terms. The domain is the collection of all first elements used in the relation. The codomain is the complete second set from which outputs are chosen. The range contains only those second elements that actually appear in the relation. For our example, the domain is 1, 2, 3. The codomain is 2, 4, 6, and the range is also 2, 4, 6. However, if the relation contained only 1, 2, and 2, 4, then the range would be 2, 4, while the codomain would still remain 2, 4, 6. This is an important difference that students often confuse. Remember, the codomain is the complete target set, while the range contains only the outputs that are actually used. Relations are used in many real-life situations. A student can be related to a classroom, a person can be related to their city, or a customer can be related to the products they purchase. In each case, we are simply describing a connection between two sets.